Hi everyone. In this video, we'll see numbers in Python. Let's get started. So here I am with my Jupyter notebook open. So in Python, basically we have three different kind of numbers. One is called as integers, another one is called as decimal numbers, and then of course called as complex numbers. So obviously, I don't think so. We need explanations for integers, decimal numbers, or complex numbers because as it is very easy. Let's say suppose I consider a is equal to, let's say suppose 20, and then if I run type of a over here, then that just actually gives me int, which is a short notation for integers. If you notice the Python 2.7 until 2.7, I guess, there is a term called long integer and just an integer. Because if you suppose say that you take this number and then run type of a, that was giving a long integer in the earlier version of Python. But Python 3 onwards, any type of integer is simply an integer. So there is no difference between the long integer or a small integer or whatever it is. So that's how it works. And after that, if you want to know what is the maximum number a Python can hold, actually it depends on your system. Because as long as your memory can hold a bigger number, that number can be easily handled by Python. So it's unlike JavaScript or any other languages that are having the specific maximum number limit is there, and after that if you try to add one or two, then it usually gives infinity. That doesn't happen in Python, so that's one of the huge advantage of Python. Anyway, so let's come back to the discussion. So you just type a number here and then write a type of a, then Python has intelligence that automatically it will define the numbers. So it just goes into the particular order. For example, you just check whether it is an integer or not. If you see that, and that designs as a means that sets as an integer. And similarly, if it checks as a floating number, which means a decimal point, that is actually setting that type as a floating number. For example, if I write 200 as 200.0, this is a shorthand way of telling that I am actually working with the float. If I run my type of a by writing 1.0 along with 200, I get a float, right? And similarly, I can also write a complex number just by like this. Let's say suppose 2 plus 3j. The way you write a complex number is the real part of the number and the imaginary part of the number. Along with that, you also have to give a j number, right? And if you compile this, then you get a type of that number is complex number, right? Fine. So that's about the numbers. One more thing we can discuss about it is you can convert an integer as a float, and similarly a float as a complex number, but not the other way around. What I mean by that here is, let me set back to my a is equal to 2, and now look at that my type of a is equal to integer, right? So what I can do here is I can just take a b as float of a, and then print b. And remember, what is actually giving you is, remember, it was actually 2, now it actually is printing as 2.0. If I even check for the type of b, that just gives me float. So any integer can be easily converted back into a float number, right? Similarly, a float number can be of course converted into a complex number, of course an integer as well. Let's say suppose we write complex of this a and then run this type of a on this b, and then what is giving you is complex number b. If you print a b, the way it prints is 2 plus 0i. That's how it works, correct? Let me zoom it a bit. Yeah, that's how it works, right? Because the real part is 2 and then the imaginary part is kind. But you can't do the other way around. What I mean by that here is you can do integer, from integer you can of course convert any integer to a floating number, and similarly a floating number can be a complex number. But a complex number, purely a complex number, cannot be an integer or uh, neither a float number. What I mean by that is, let's say suppose we'll assume c is equal to 2 plus 3j. That's my complex number. If you print c, then that is gives this. And if you also see the type of c, it is a complex number. So like I have done here, where I was just converting b into a float number. If I want to run the same thing on the c here, remember c is a complex number, I'm trying to convert into a floating number. Of course it doesn't make sense if you see that cannot convert complex to float. That's not the error you get it. Of course, this does make sense because it does not know how to convert a purely a complex number into a floating point number, right? Um, uh, yeah, I think that's all it does for the numbers. Of course, you can use to do all the natural way of addition, multiplication, scalar multiplication, everything you can do. And similarly, you can also perform this kind of operations from integer to float and float to complex. There is no restrictions on it, right? If I say, let's say, suppose a is equal to 2, which is a type of integer, and b, let me of course consider as 3.2. If I see the type of number b, that's a float, and if I see c, that's actually 3.2j, 3 plus 2, 3j, which is a type of complex number. Now let me compile that also for the safer side, and now try to add a plus b. That gives you 5.3. Remember, one was a integer, another one was a floating number, right? If I see this type, let's say type of this a plus b, as expected, it's a floating point number. The way you think of this is integer is a little subset of a floating point numbers, and floating point numbers is subset complex numbers, etc. So in that regard, you take an integer and add it with a floating number, it will consider as a as itself is a floating number and add it with that. That's how it works. Similarly, if you add a plus c, then the type of the number is complex number. If you see what is a plus b, of course, and that does also make sense. If you see this a plus c, and that's 4 plus 3j. Note that this is 2 plus 3j, and integer has been of course converted into a complex number, which was having only the real part as the value of a, which is 2. So 2 plus 3j, 2 plus 0j plus 2 plus 3j was 4 plus 3j. That does make sense, right? Yeah. So you can do the multiplications, addition is in this manner as well. Let me of course give a small introduction about, I mean, just multiply a star b, that does work, a star c, that does works. Yeah, now you know what to do right now, so you can go ahead and play with this multiplications and check for different types and other stuff. It always takes a superset. That's all you have to keep it in mind. All right, that's all for this video, and I'll see you in the next video. Thank you.